Alright, we're at practice test 4, video 3. We're on question number 12 now. We have a parallelogram. It's actually number 12. And this parallelogram is 6 centimeters and 14 centimeters long for the sides. So, let's say we'll put the longer side this way, let's say. Okay. And let's say that's something, that's 6. And then let's say this is 6, 14, 14. Looks something like that. And we know the shorter diagonal is 10. So the shorter one is going to go between the two obtuse angles like this. So that's 10. So I'm going to start by finding this angle right here. Let me call that A. So this is A. And then this, say one of these is B and one is C. Okay? So we know A is the inverse cosine of B squared plus C squared minus A squared over 2BC. So, oops. So let's start up my calculator here, and we're going to work this out on the calculator. So let's see, let's go to mode. I'm in degree mode at the moment. That's fine for what I need here. So I want inverse cosine of B, which is 6 square, plus C, which is 14 square, minus the 10 square, close the numerator, divide by, open the denominator, 2 times the B and the C, the 6 and the 14. Okay, so this is going to be angle A. So angle A is about 38.21 something degrees. Okay? Now, that means in a parallelogram, opposite angles are the same size, and then these two are the same size, and these two are supplementary. The four angles add up to 360 degrees. So these, I need 180 minus that. Okay, and that's going to give me the angle there, say down here at the bottom. So if I redraw this part at the bottom here, and draw in the long diagonal here, we know this angle here is the 141.787 degrees. We know this side is 6, this is 14, and we want to find this side here. Let's call that C for the diagonal. So this is angle C, and again I'm going to call this guy still B, and this guy, well, I called it C before. Well, let's call it C again. So then that would make this angle A here, different from this angle A. So relabeling. Okay? So we want to find side A. In this new triangle here, it's the square root of B squared plus C squared minus 2BC cosine of angle A. So what's that going to be? That's going to be the square root of B, which is 6 square, plus the C, which is 14 square, minus 2 times the 6 times the 14, times the cosine of the angle that we just figured out, so my previous answer, close, close, enter, it's about 19.1 centimeters, or units. Next question. Find the area, and we have a side angle side situation. So we have A is 23, C is 17 kilometers, and angle B is 38 degrees. So anytime you know two sides and the angle in between, the area is the product of the two sides one half the product of the two sides times the sine of the angle in between. So 1/2 9 kilometers times 17 kilometers times the sine of the 38 degrees. So 0.5 times 9 times 17 times the sine of 38. Enter. That's about 47.1, and that's square kilometers. Square kilometers. Oh, where did I get 9? It's 23. Oh, that was A. I can't read my own writing. 23. Okay, try again. 0.5 times 23 times 17 times the sine of the 38. There we go. About 120.4 square kilometers. Okay, next one. Quantity has both magnitude and direction. It's called a vector. Okay, label the vectors that we want to add them. So we've got V is here. If this green one is U, let's see. Okay, so if you went U, then V, this would be U plus V, and the opposite of that would be U minus V. So the red one could be U minus V, or W instead of U. So W minus U, sorry, the opposite of W plus V, or V plus W. Okay, so let's see which one of those would work. One way is to let the green one be W, and then the red one be minus the opposite. So C would work. No, I'm wrong. Let me say that again. Yeah, if you start with W, then go to V. That's the same as starting here and going here. That's the direction we have. Sorry, I thought the arrow was the other way. So we go this way. That is W plus V, or V plus W. A is correct. Next question. Okay, magnitudes are 2 and 5, so the magnitude of vector V is 2, magnitude of vector W is 5. The angle between is 60 degrees. Find the magnitude of the sum. So let's see, here we've got, so if we go V and W, here's the vector W, here's the vector V. So if we sum it, we move V over here, and then the sum here, W plus V, or move the W up here first, it doesn't matter, that's supposed to be a parallelogram. You get V and then W gets W plus V. Let's do it that way. So V plus W is across here. This guy is 2, and then 5. Okay. And the angle between them, when we put them down here, that angle is 60 degrees. That means this angle up here is 180 minus that, so it's 120 degrees. So now we basically, let's boil it down to solving a triangle where this is 5, this is 2, and this is 120 degrees. And we want to find this, all we need is the size of this. So let's call that C. Okay? And C is, we can use law of cosines. Square root of, let's call this guy A and this guy B. A squared plus B squared minus 2AB cosine of angle C, which of course is 120 degrees. And then we just fill in the blanks here. 2 squared plus 5 squared minus 2 times 2 times 5. So, square root of 2 squared plus 5 squared minus 2 times 5 times cosine of angle 120, close, close, enter, is about 6.2. Okay? Okay, notice real fast that when we talked about the angle between the vectors, we were putting them tail to tail, like that. But when we add them, we're putting them tip to tail. So if we had this was 60, this one turns out to be 120 because this is parallel. Okay, we got another application with some vectors. Powerboat is crossing a river at 23 miles per hour, bearing north 76 degrees east. So here, let's put as a reference here. Okay, north, south, east, west. Let's go right along these lines here. So north, 76 degrees east. It's going to be kind of like this. 76 degrees here, northeast. And it's 23 miles per hour. So there's our vector. The current of the water is also pushing the boat, and it's north 25 degrees east, and we're going to add these two vectors to get the actual speed and direction. So I'm going to write this vector right here. North 24 degrees east. So this is 24 degrees here. And it's not nearly as long. It's only, make it pretty short here, only 8 miles per hour. Okay, so the resulting vector that we're looking for is across here. And we want to find the magnitude and the bearing for that one, okay, for the red one. Okay? Well, not to there. Sorry, that was the wrong place. To here. When you add the two vectors. Okay, so what do we have? Well, let's kind of isolate it like this and look at our triangle. There's our triangle. We know this guy's 8, this guy's 23. This is, say, C. Well, what angle do we have here? Well, this is 71. So if we make a right angle there, we know this one is the 24 is this. We know 71 to there, to here. So that leaves a total of 90 minus 71. That's 19 degrees here. And so this one's also 19 there. So if you take the 19 plus the 90 degrees plus the 24 degrees, okay, you're going to get the angle right here. So that angle is 133 degrees. Alright, now we can solve for side C using the law of cosines. Square root a squared plus b squared minus 2ab cosine of angle C. One of these guys is A and the other one's B. let's say A is this one, B is this one. 8 square plus 23 square minus 2 times 8 times 23 times the cosine of 133 degrees. So it's very important that you draw the picture. That makes a big difference. So square root of 8 square plus 23 square minus 2 times 8 times 23 times the cosine of 133. And this is going to be the magnitude or the distance, 29.05125.465. And these are the magnitude, which is a speed actually in this case, miles per hour. Okay, so okay, got 28.6. Let me make sure I didn't do a mistake here. 76. I have 71. Okay, so that's going to change things. So that leaves 14 degrees there. So this is going to be 5 degrees less. So let's just redo that. 14 plus 90 plus 20. Let's make sure. 24. It's 128. Okay, now let's go back and get that. There it is. And change it from 133 to 128. Come on. Now this should be right. 28.6 miles per hour approximately. Okay, now let's see the bearing. Now we can find this angle at A. Okay, so let's find that angle at A. We know A is the inverse cosine of B squared plus C squared minus A squared over 2BC. So that's the inverse cosine of B is 23, A is 9. And then this is just my previous answer, which I'm just going to call C for the moment. That's the 28 point whatever. Okay, but I've got it as my previous answer. So I'm going to do inverse cosine of 23 square plus my previous answer square minus 9 square. Okay, is that right? No, it's 8. Get it right here. That's A, and that's 8. 8. And I'm going to divide by 2 times 23 times whatever my previous answer was there. Okay, I think this is right. About 12.72 degrees. Okay, now that's the angle. Let's see where that is. That's the angle right. Let me get a different color. That's the angle right here. Okay, so the bearing is the angles right up here that we want. Okay, so it's 76 minus what we just did. (63.3 degrees). So it's north 63.3 degrees east. And there we go. Okay, let's stop there and we'll put the rest in the next video.